Welcome to all. I am starting question number 94. I already wrote for some reason. Actually, this question is 94. I am dictating now. Actually, 94, 95, 96, 97, all recordings are over. Then suddenly, when I saw the recording, during editing time, I just always glanced through. At that time, I found a mistake. See, in the question, I told, this surface, mu is, this, I'll put here, this surface, I told mu equal to 0.25, and this surface, I told mu equal to 0.2. 0.2 in the question. I wrote the question here neatly. But unfortunately, when I solved, I forgot that one. I saw only one number. I took 0.25 here and also 0.25 here. So, I should give a correction. Either I should put correction in the description box. No, I don't like it. Some may not see it. Some will tell he gives different mu values and takes the same value. See, comments will be there. Therefore, I decided to re-record. So, therefore, already time is lost. So, I am dictating the question. First, do one thing. You correctly write the question. Slowly, I will dictate. A ladder weighing 400 Newton has its center of gravity at a distance of 0.45 of its length measured along the ladder from bottom. See, a ladder weighing 400 Newton has its center of gravity at 0.45 times of its length along the ladder from the bottom. Okay. Top of ladder is 3 meter above ground level and the bottom of ladder is 4 meter from the wall. Coefficient of friction for the contact point of ladder with the ground is 0.25 and for the contact point of ladder with the wall is 0.2. Question is, find the least vertical push required to be applied at the bottom of the ladder to prevent it from slipping. So that means the person who gave the question, he feels that this ladder is unstable. So since it's unstable, this I told you earlier, there are so many ways to prevent it from slipping. So they want what? Least P. So you start the question from there. See, start the question from there. See, first red color, unknown. Let P be least vertical push to be applied to ladder at bottom to prevent it from slipping. So least means what? On the verge of slipping. So limiting will come. Okay, now first do one thing. You write some preliminary part. See, in the question I told you, this mu is 0.25, this mu is 0.2. I told top of ladder is 3 meter from here, bottom of ladder is at 4 meter here. So length of ladder, if you want, equal to root of 3 square plus 5 square, 4 square. So you get length 5 meter. Weight, I told how much weight? I told 400 Newton. I told the weight of ladder is acting at 0.45 of L from the bottom. That is not midpoint, little before midpoint. So this will be equal to 0.45 of 5 equal to 0.45 of 5. How much? Okay, not required. See, you write 0.45 of L sufficient. Okay. How much is not required? Okay, leave it now. Now, something else. I'll remove this one now. See. Now, see, this is 4 meter. When you project here, I want what is this length? See here. This is 0.45 of length means this is 0.45 of this length 4 equal to 1.8 meter. I thoroughly explained for you. what ratio is this point with respect to this point, this length. Same is the ratio here also. See, this is 0.45 of length means this is 0.45 of 4. So that's why I wrote 1.8 later here. Then usual statement of usual limiting friction you should write. See, write RA, RC, you write. Then ladder slips this way, friction force here, how much it is? 0.2 times RA, 0.2 times RA here, you write here limiting friction. Here limiting friction is, you should write correctly, FF limit at A, right here, FF limit at C is not this way, 0.2 times of RC. If you are interested, if you want seriously studying, you should write what? FF limit at A is mu A into RA. Mu A is given 0.25, this is 0.25. See, once again I am about to make mistake. This is 0.25 given. 0.25 into RA, there 0.25 RA, there 0.2 RC. Why friction this way? Slipping down means up, slipping left side. Then, see, now how to, I told already, when a ladder is slipping, one of the option is go to bottom and press it down. So they want how much P required. So the person who said the question, he thinks that, I only thought, the ladder is not stable, therefore he is pressing the ladder down. This all you write yourself only. I do not want to waste time here. This is a preliminary part to do it. Then write this also over, this also over. Okay. Consider free body diagram of the ladder and apply equilibrium conditions. Now nothing is there. Now I need not explain anything. Only look at the board. You should be able to solve. See here. Over. See. RA 0.25 RA. RC 0.2 RC. 400 acting at 1.8. That 5 meters is not required. Okay, start. If you see there, it is sufficient. Sigma Fx0 plus 0.25 RA minus RC equal to 0, equation number 1. Sigma Fy0, upward positive, minus P plus RA plus 0.2 RC minus 400 equal to 0, equation number 2. Sigma M about A0, this all I explained for you earlier. Minus RC into 3 minus 0.2 RC into 4 plus 400 into 1.8. Suppose that center of gravity is not given, you take midpoint, then this is 4, this will become 2 meter. Now it is 1.8 equal to 0. You get RC, substitute RC in equation number 1, you get RA, substitute RA and RC in equation number 2, you get the value of P. See, for the P, you got positive answer. Make a note here. Positive sign indicates that the direction considered is correct. That means, yes, you require a vertical push-off. Suppose any calculation mistake is there, correct it. 397, almost 400 Newton, that is almost equal to weight of ladder. As much extra weight, you have to press it down. Now, by chance, the power gone there. Okay, I will manage. 1 minute, something wrong there. Little loose connection. Okay. Some concept is there. By chance, if the ladder is already stable, suppose that means it is not on the verge of slipping, it is not even slipping, then this vertical force is not required. Negative will come. If you get negative, that is what will happen in the next question. Okay. Next question, the person who said the question thought that ladder will slip, but it is not slipping. I only said the question. I will give it deliberately, as if I am not knowing subject. Okay. And by chance, if this ladder is on the verge of slipping, then your P will come 0. See, if P is 0, ladder will not slip. It's on the verge of slipping. If P is positive, yes, correct. You require that much to prevent the slipping. If P is negative, the ladder is stable, instead of pressing down, that much you can lift up also. But lifting up ladder is dangerous, permitted up to some limit, okay. See, when very rough surface is there, if you go to bottom, if you lift also nothing will happen. But if the person who is climbing will have tension, up to some limit nothing will happen, then it will fall down. Okay. This is question 94 over now. Now I will go to question 95, already gone, I will join it. '90, 91, 92, 93, 94, 95. Okay, correct. Now, see. A ladder weighing 900 Newton. First preliminary part, then I am rubbing it. 900 Newton is resting on a wall, on a vertical wall, understood, wall is vertical, at an angle of 30 degrees. So, the ladder is like this, see, this way. So, this looks like a stable ladder, you can see here, see, look like stable. This angle they told 30 degrees. So do one thing, immediately this angle will be 60 degrees. Remember, not given, we got it, because we prefer this angle. Length of ladder is how much? Length of ladder is 8 meters. And last time weight was given per unit length. Now weight of ladder is 900 Newton. But they told center of gravity of ladder is at 3.75. So therefore it is not midpoint. It is somewhere here, see. Somewhere here, it is how much? Weight is 900 Newton. So along the ladder, this point where weight acting is 3.75 meter. Okay, this is clear. This side, now. Therefore, first do one thing, preliminary part. See, this length you require and this length you require. This all I explained for you earlier. This is 8 meter means this is 60 degrees, 8 cos 60 equal to 4 meter. 8 cos 60. This is 8 cos 60. This is 8 sin 60. 8 sin 60 equal to 8 into sin 60. 6.9282 meter. 6.9282 meter. I will forget later. I will make a note. I will make a note because I am rubbing. 6.9282 and 4 meter. I will forget later. Okay. Weight is 900. Weight is there in the question. Okay. This is clear. Then, see, as usual, you write, see, this all, we have to write yourself only. See, normal reaction here. This point I will call C. This point I will call C. This point I will call A. Okay, A. This side I will write A here. Space problem. Okay. This side I will call RC. This side I will call RA. Slipping is this way. This is what? FF limit. I am writing FF limit for C equal to whatever mu at C. I am actually explaining unnecessarily for you into RC, and in the question they told this contact surface mu equal to with the wall is 0.4. 0.4, this will become 0.4 RC, and this here, it slips this way, friction is this way. This is FF limit at A equal to whatever is mu at A into RA, and mu at A in the question given how much? 0.4. No, 0.36. See, with the wall is 0.4, ground is 0.36. 0.36 into RA, this is a usual. Okay, then further, this all you are right. Then when you project this length here, see, this length you require. See, when you take moment, this length equal to, see, this is, if the weight is acting center, then this is 4 meter. When you project here, you get 2 meter, but 4 by 2. This time it is 3.75. So this distance is 3.75 out of 8 ratio. 3.75 by 8 into what? Into this length 4. Calculate. 3.75 divided by 8 into 4 is 1.875 meter. Or you can do one thing. See here. You can do one more thing. Cos 60 equal to, see here, cos 60 equal to this side by 3.75. So this side is 3.75 into cos 60. Yes, 1.875 meter. Now in the question, what they want? What is the least weight to be placed? So start from there. See, last time they want what is the least vertical push required. This time they change the mind. See, last time they are asking somebody, hey, come here. The ladder is in danger. It may slip. So do one thing, go and press the ladder like this. Now he is thinking, no, not that way. They will tell, bring a stone and tie it to the bottom of ladder. Or at the bottom, you put a weight at there. So therefore, both are same. See, they are asking you, what is the least weight? You call W now, pending. See, let W be least weight required. Least weight, what they want? Least weight to be placed. To be placed where? Here at the bottom of ladder. Right here, at the bottom of ladder to prevent the ladder from slipping. This all statement you write. Everything is ready. Now you can go for calculation. I will do one thing now. I will go for calculation. Okay, 1 minute. Okay, now I will do one thing. To save the time, I will write the sketch and start. Because now nothing is there. Waste, see, rubbing time and then write calculation time. I can save it. You can do it yourself only. Okay, I fully solved, nothing to explain. See, first sigma fx0 plus 0.36 RA minus RC0, equation 1. Sigma fy0 plus 1 plus minus W, unknown first, minus W plus RA plus 0.4 RC minus 900 equal to 0, second equation. Take moment about A. Minus RC into 6.9282 minus 0.4 RC into 4 plus 900 into 1.875 equal to 0. RC will come. Substitute that RC in equation 1. You get RA. Substitute RC and RA here. Your W will come minus 271.204. Make a note. Negative sign indicates that, see, no load is required. See how much you have to apply vertically downward load. Negative means if you want, you can even lift it up. Or you can tell the ladder is already stable. See, in the given position, with only weight of the, if some person is there, something else, it will come later. See, in the given position of ladder, given angle, it is already stable. There is no slipping. When there is no slipping, why you want to prevent slipping? So that is the person who set the paper, his ignorance. Don't tell my ignorance. I told deliberately I set the question to get negative sign. Okay. Now 95 over 96. This time I will save the time by writing the question and solving. Because simple question. Now, next question. See, a ladder of length 7.5 meter and weight 1.2 kilonewton is resting on a vertical wall where coefficient of friction is 0.3. So therefore, see, when you prepare the sketch, you have to make a note here. Preliminary part. See, this is the ladder. Length of ladder is 7.5 meter. This all I will not explain. And weight is to center is 1.2 kilonewton and They told this coefficient mu is how much? 0.3. 0.3 they told. Okay, see they told where what coefficient of friction is 0.3 and the ladder makes an angle of 50 degree with ground level. See, this is 1.2 kilonewton, 1.2, this is 50 degrees and they told with the ground which is smooth. Oh, this is smooth. Very, very important. So now you know it. This ladder can never stand as it is. Why? I told, if ground is rough, wall is smooth, you can manage. So up to some limit, okay. But if ground is smooth, some extra effort required. Okay, then I'll take A, B, C, D, you write yourself only. See, A, B, C, all you write. Okay, then find the least push required to be applied to the ladder at bottom to prevent it from slipping. They are 100% sure that this ladder will slip. So you write the statement here. See, let P be the least push required to be applied to the ladder at the bottom to prevent from slipping. It is like this. Why? It is like this. Friction is not there. Least push required. It is like this now. Okay. So now, that's all. Now, before going further, see, I will not waste time now. This is 7.5. So, see, I remove this one now. So, this length will be 7.5 into cos 50. That will come 4.821 meter. Third decimal sufficient. And this point I will remove now. See, this rough mu is 0.3. Okay. This vertical height will be 7.5 into sin 50. 7.5 into sin 50. That will come 5 equal to 5.745 meter. Okay, then this weight will be acting exactly center. How much? 4.821 divided by 2 equal to see 2.4105 meter. Then friction, see here, as usual, right here, normal reaction RA, you should write. Here, normal reaction RC, friction is there, frictional force is FF limited C equal to mu C into RC. Mu C they told 0.3, it is 0.3 into RC. This all you are right. If you are serious, you write. Okay. Now consider equilibrium. See here, RA, P, 1.2, everything I explained. Now nothing is there. Only calculation part. We'll do it now. Nothing to worry. Not a big issue. After this one, small question is there. I'll tell you that question. Okay. Last question. Play. All small questions. See. Start. Sigma. You write the sketch and start. See, I forgot ABC. Okay, ABC. Okay. Sigma Fx equal to 0. Take right side positive. What do you get? Plus P. See here. Plus P minus RC. That's all. Minus RC equal to 0. Equation number 1. Sigma Fy0, take upward positive. Plus RA, then plus 0.3 RC, 0.3 RC minus 1.2 equal to 0. Take equation number 2. Then sigma m about A equal to 0. Take clockwise positive. Minus RC into 5.745. Again minus 0.3 RC into how much? 4.821. Then plus 1.2 into 2.4105 equal to 0. From this one, you get the value of RC in Newton. Okay, get it. RC will come in Newton. That is 1.2 in this time, not Newton, sorry. This time question is in kilonewton. So you stick to kilonewton, not Newton. Answer will come in kilonewton. Okay. 1.2 into 2.4105, that number divided by 5.745 plus 0.3 into 4.821. Correct? Yes, correct. 0.402. RC will come plus. If it is wrong, correct later. 0.402. RC came. Now, oh, that's all. See, your RA is not required. Therefore, substituting in 1, you get the value of P. RA is not required. Okay. But if you want to calculate, if you are interested to calculate, substituting in 1, you get the value of P in kilonewton. Oh, P equal to RC equal to plus 0.402 kilonewton. Because P equal to what? P equal to RC you got. Okay, now, last question. This over now. See, 96 over 97. This time, what I will do is, I will make the wall rough and, ground rough and wall smooth, and to prevent the slipping, not push, I will tell a cable is attached, cable or rope etc. is attached to the bottom. Last question. I will do one thing, that question is exercise question. So briefly I will solve. I will write everything and explain. See, now 90, 90, 91, 92, 93, 94, 95, 97, correct. Okay. See, now a ladder of weight 600 Newton. Okay, see, I will put one by one. Preliminary part. This I will not explain again and again now. See, this way. Weight 600 Newton. If not given, understood, acting to center. I will take this as A, this is B, this is C. And remember, he is resting on a smooth vertical wall. Therefore, this wall is smooth. Remember. Therefore, right here, no friction here. No friction here. Later, only normal reaction. Okay. Make a note. And the top of the ladder is 3.6 meter above ground. See, the top of ladder is 3.6 meter above ground. And the bottom of ladder is at 4.2 meter from the wall. See, this is 4.2 meter. Now, weight is at center, so therefore later this will be 2.1 meter. See, this time length of ladder is not required for us. Even angle also not required. Why? Not required. If you want to calculate, see, suppose they give weight per meter, you require length. Okay, then that's all. So here, coefficient of friction for contact point of ladder with ground is 0.32. So this ground is rough. So therefore, here normal reaction RA and a frictional force, see, slipping this way, friction of how much? They are told 0.32. So 0.32 times RA. This I won't explain now. If somebody is not clear, don't continue my class. 0.3. Suppose now it is not clear. 0.32 RA. Now what they want? See, the person who said the question, he thought this ladder is not stable. To his mind it came. To his mind it came. I will tell you what is the angle here. 3.6 and 4.2. Somehow to his mind it came that this ladder is not stable. 1 minute. I will do one thing now. To make more clear, I will give low friction so that 0.12. Very low friction. Okay, now good. 0.12. So that way, no chance I am taking. Okay, otherwise negative will come. Okay, 0.12. Almost little rough. So how to prevent? One question we told, apply a push here, over. Second question, weight to be placed, same as push. That question, a push this way, see, that will help the friction. This time, see, common sense. They told, see, green color, to prevent the ladder from slipping, a cable is attached to bottom of the ladder. I will ask somebody going on the road, this ladder will slip. Shall I tie a cable inside or outside. Somebody on the road will tell, sir, tie it inside, sir. Why? When that ladder is slipping there, the cable will prevent it. So therefore, the cable is like this here. This is the cable. Attach here. This is the cable. Somewhere attached. Okay. Where? Maybe somewhere here attached. Therefore, let T be tension in the cable. This is the tension in the cable T. This is not a free body of ladder now. All preliminary part. See, this is all preliminary. Later, when you consider ladder, this is not there. See, at the point AT, this will not come. Why? This is somewhere else. This you know thousands of time earlier. Later, a tension will come T here. And remember, so this question is same as last question. Last time P, this time T. Okay. Now, on the board, I will write solution and not explain much and close the class. 1 minute. I solve the question, nothing is there. See, sigma, I put one more sketch here. Consider the case, you write here, consider equilibrium of ladder, then sigma fx0, what you get, plus T plus 0.21 RA minus RC0, equation 1, sigma fy0 plus RA minus 600 Newton is 0, RA will come, take moment about this point, minus RC into 3.6 plus 600 into 2.10, RC will come, substitute RA, RC in equation 1, you get T. Okay, question over. Now, next class we will go for question number 98. Okay, now, one important concept. Some student asked, sir, what? Sir, you have shown only one T. Tell me what is your problem? Sir, there is one more T here. See, suppose, sir, the question is over now. See, he told, suppose the cable is this way, sir. There is one more T here. That T, why you are not accounting? Sir, the T and T will cancel. I will ask, this is the first time you are doing? Have you not done earlier? See, earlier question, when you are showing tension T, when you consider equilibrium, only one of them you are considering. See, to the ladder, this T is acting. That T is acting on what? Some surface there, some fixed support. Then I will tell, in that case, do one thing. Suppose, imagine it this way. There's a reaction of T here. Oh, got it, sir. These two will cancel each other. See, when you consider the ladder, that cable will pull it this way. That's all we want. See, which is in contact with the ladder? This T. Consider that one. That T is not in contact with the ladder. It's other end. Just to understand. Okay, over. Now, solve all the questions. More and more questions we'll solve. See, 97 now. Maybe another 10 questions I will solve. See, I will make complete course of this ladder friction so that complete friction chapter is very thoroughly covered. Maybe another 2 or 3 classes for ladder. Then we go for strength of materials. In between, I will upload some more classes, importance of strength of materials, and something else I want to upload. Okay, that I will tell later. Now, that's all this class. Next class we will meet. Thank you.